Hi everybody, welcome to the with this webinar. It's Jonathan Brindley here from JBUAS. I'm really pleased to be here with a colleague, Troy Messler from SkyFront, who are manufacturers of the perimeter array hybrid electric endurance UAV. Going to spend quite a lot of time talking about this drone and its special capabilities. But before we do, I'd like to just, if I can, touch on a little bit about what we're going to talk about. So this is a quick agenda. We're going to have a little bit about ourselves, JBUAS, and then we'll talk about all the specification of the perimeter array, its capabilities and special features, which it has many. Talk about the sensor payloads that it's carrying, and also look at touch on, if you like, some UGCS integration as well. And at the end of that, which will probably be about 30 to 40 minutes, we'll have a Q&A for 10 minutes at the end. So if you have got any questions, please fire them in, and I'm sure Troy will be able to answer these. So. A little bit about JB Unmanned Aerial Systems. So JBUAS is partnering with SkyFront in the UK. We are a reselling agent for SkyFront, and we are at this very moment, in fact, working on projects for the perimeter array. Yeah, it's a very exciting time for the drone. It's got some capabilities that are really useful to quite a number of sectors. Not to mention sectors such as geophysics, defence, oil and gas. The list goes on and on. Just to name but a few. So yeah, very pleased to be able to bring the CEO here, Troy Messler, from SkyFront. Sorry, to talk to you today. So let's just talk about just a little bit about what we do here at JBUAS. Some of you might already know that we are involved very much with looking at UGCS integrated systems. We also deal with Workswell as well. So we are dealing in thermal systems. We're dealing in methane laser systems, which we've worked with a number of OEM in the UK. We're also offering GPR systems for a number of applications, such as archaeology, utility detection, sediment analysis, soil analysis, and again, the list is long. Also dealing other systems like echo sounding systems. A number of projects on at the moment for echo sounding systems, both single frequency for just bathymetry and dual frequency for sub-bed sedimentation analysis. Also working in magnetometry. A lot of you that are on this call, on this webinar, will be well aware that JBUAS does a lot of work in this regard, working quite closely with Census. And in that same vein, yes, also just recently, actually, we had quite a few inquiries and a couple of potential projects for the new metal detection system. So that's another system that is starting to get noticed. Yeah, so there's a little bit about the systems that we're dealing with. As it says there, we're looking at integrated systems, not just for DJI drones, but also for non-DJI drones. And SkyFront and the perimeter array is one of those drones that is it's got a lot of capability, and it's something that we're quite pleased to be carrying here and able to offer our clients. So lastly here, just a little bit about how we can support you. Yeah, JBUAS, as I said before, working very closely with SkyFront, with the perimeter array on projects right now as we speak, projects that are going forward. Perimeter array sales, no problem. Sensor solution sales, also able to talk about the UGCS Sky Hub and the True Terrain, or offer services in terms of configuration and trial days, So the total integration can be done through ourselves. So if you're looking at a sensor package on a non-DJI drone or a DJI drone, then please come and see us, get in touch, and yeah, we can really help you down that journey of taking on the technology and getting the best from it and getting a really good ROI. So which is what it's all about. So anyway, that was just a little bit about JBUS. We're really here today to talk about SkyFront's Perimeter 8. It's a really exciting drone. Like I said, I'm really happy to be able to carry this this drone because I think it's got so much capability and is being used very widely indeed. And I don't think enough people know about it. So it's a great opportunity now to introduce Troy Messler, CEO of SkyFront, who I'm very pleased to be able to introduce. So, Troy, the floor is yours.
Thank you so much, everybody. Thank you for having me. It's a pleasure to present in front of you all today. Let me share my screen here. Give me a second. Can everybody see my screen? Awesome. So yeah, my name is Troy Messler. I'm the CEO and founder of SkyFront, and we are the manufacturer of the longest endurance multi-rotor UAS on the market today. I started this company back in 2014 to solve the payload and endurance limitations of drones. Fast forward to today, and we manufacture the longest multi-rotor drone in the world. It's called the Perimeter SUAS. It's a hybrid electric drone, so it converts gasoline into electricity while it's flying. And in doing so, we can take advantage of the high energy density of gasoline, and we can fly 10 times farther and longer than traditional battery-powered drones. I designed this aircraft to replace manned helicopters. Because helicopters are expensive, they're heavy, they're not on demand. You can't just call them in whenever you want. You have to schedule them. and most importantly, they're dangerous. For a lot of these missions, you know, you're flying close to the ground, and there are power lines, trees, other obstacles that are in the way that make you know, collecting that data very, very treacherous. So that's what we do in a nutshell. And we're, you know, this is our first product, but, you know, we're actually looking to scale up, you know, in terms of the size of our drone, carry larger payloads, and, you know, someday in the future, potentially carry cargo as well as human beings. As I mentioned, we hold the endurance record. Back in 2021, we actually flew the Perimeter 8 for 13 hours and 4 minutes. Let me just share a video of this. Give me a second. So we took off before sunrise, and we touched down after sunset, and we collected in a single shot the full arc of the sun. So that had never been done before. That was really exciting. And it was a, you know, we don't sell a drone that can fly for 13 hours. It flies between 5 and 6 hours. But you know, we did this flight as a demonstrator of, you know, our technology and what we're capable of doing as a company. Let me move back to the presentation. Give me a second. Just to give you an overview of the product, so the Perimeter 8 can carry about 10 kilograms for 1 hour. So this is a industry-leading specification. We sell models configured with different types of radios that can get video and command and control up to 50 kilometers away. In fact, we did an acceptance test for a Navy in Southeast Asia recently, where they told us we want to see it go to 50 kilometers. So we took off and we flew it out to an island, and then we came back 50 kilometers out, 50 kilometers back with full video the entire way, no dropouts whatsoever. We have an endurance with our extended fuel tanks. We can get up to between 5 and 6 hours of flight time. Our max takeoff weight is 26 kilograms. It can actually carry more weight than that. It's just it's for regulation purposes that we keep the number lower. The size of the aircraft is about 2 meters by 2 meters. And it actually breaks down into 2 cases that can be carried on board a commercial airliner. So it's got a small form factor, small-ish rather. It's still a big drone, but it can be operated by a single person. It can be transported by a single person, and it can be transported in the back of like I said, or on a commercial airliner, or in the back of a small car. We've done that a number of times as well. We've tried to make the operation of the vehicle as easy and as seamless to use as possible. So it's got an auto start. So basically, whatever you are used to in terms of starting a battery-powered drone, the arming of that is the same thing for the Perimeter 8. It has electronic fuel injection, so you don't need to worry about tuning or anything like that. It's handled for you automatically. We're able to operate in low temperatures and high temperatures with ease. And we have a low logistical footprint, so you're not carrying with you, a ton of cases as some of the larger UAS systems require. In terms of environmental robustness, we're capable of operating at 4,000 meters density altitude. We have a few customers, some of which, that are a high altitude, some of which are in Colorado. One of our customers, I believe, flew a 4-kilogram payload at 12,000 feet density altitude. So that comes out to about 4,000 meters or so, or just under 4,000 meters. In addition to payload and endurance, we also offer a number of what we call advanced capabilities that are specific to the types of applications that JBUAS is interested in, and JBUAS's customers are interested in. 2 of those are active terrain following and seamless command and control handoff. So we have a downward-facing radar on board the aircraft that measures the height above ground level, and using some algorithms, we're able to maintain a fixed distance above the ground level as the drone is moving forward. It's important that the sensor is actually a radar instead of a LiDAR, because radars can operate over water or wet environments with ease. And they have a little bit longer range than some of the LiDARs do. Let me just show a video of this in action. Wait a second. So I believe these are some flights that we did in 2020 or 2021. But we went up a fairly steep hill and tested our terrain following out pretty extensively. We were able to get about 2 meters above the ground level and go up this hill. And we went up multiple times. We basically did a raster scan, or excuse me, a Lamar pattern on this hill, going back and forth. You might wonder why that is important. Well, if you're carrying some of these sensors like ground penetrating radar or magnetometers, they have they need to be close to the ground in order to get good data. And that's what we allow them to do. One of the other features that we have is called command and control handoff. So some of our drones are equipped with mesh capable radios, meaning that you can have multiple radios and they can all kind of talk to each other. And so what we do is we create this mesh network. We equip the drone with this type of radio, equip multiple ground control stations with this type of radio. And then using some hardware and some software, we're able to allow any pilot on the network, any pilot with a ground control station and a radio, to view the data that's coming from the aircraft, and also to initiate a command takeover by simply flipping a switch on the remote controller. And this is really essential if you're going to be operating over large areas of land. And to also maintain compliance, right? So in a lot of countries, there's this thing called beyond visual line of sight, and it's not really legal right now. This is a way to kind of get around that, right? So you can operate the drone a long way away, but if you have someone on the other side next to the drone, they can always take control, and you can check the box in terms of compliance. This is really, like I said, our mission is to replace helicopters. And in order to do that, we have to be able to operate a range, regardless of what the regulations are. So this is a way to do that. And in that way, you can increase your return on investment, right? You can carry more, you cover more land in a single flight than you could with traditional battery-powered drones. One of the biggest applications for us is LiDAR surveying, and to that we have integrated pretty much every LiDAR on the market today, including ones from Regal, Phoenix, Routescene. They're a UK company. Yellowscan, Geodetics, GeoQ. We have a lot of experience with all these different LiDARs in terms of vibration dampening, how to operate them, how to power them, and how to eliminate any noise that might be coming from the aircraft and affecting the data. So all of that has been tuned out. Some other applications that we have spent a lot of time on and have a lot of experience with are photogrammetry surveys, geophysical resource exploration. So as we speak, there are multiple drones that are being flown with magnetometers on them here in the United States and abroad, looking for, mineral deposits, oil. We also have a lot of drones that are being used for oil wellhead detection. I'm not sure how big of an application that is outside of the United States, but in the United States, we have a lot of abandoned oil wells all throughout the country, and it's a big problem in terms of leakage and preventing environmental disasters. We also have drones that are used for unexploded ordnance detection. Think mines, unexploded artillery shells, things of that nature. We're really excited to be partnering with JBUAS, and they're a reseller for a company called UGCS, which is they make a ground control station software, which we're compatible with, that has very excellent terrain and mission planning features. So, one of the, I would say, we make our own ground control station, and it's good, but it doesn't have that level of sophistication that UGCS has, I would say, right? And UGCS allows you to kind of look at the terrain in 3D to be able to plan this. If you look at the screen on the right, be able to plan your missions and make sure that the drone that you're going to send on a mission is not going to hit anything and is far away from terrain as possible. So about 20% of our LiDAR customers and about 80% of our magnetic survey customers use UGCS with our drone. We recommend it if you're going to be operating in really steep environments, for sure. One of the, we offer active terrain following as well. It's good, but it's not meant for areas with trees and cliffs, things that have steep changes in elevation. It's really good for large open areas, and this is where UGS would really complement. It does really complement our drone very well, because what we can do and what we have, what our customers do actually, is they take a small, cheap LiDAR unit, they go and they fly a mission with it, they collect LiDAR data, and then they create a digital elevation map, which they then upload into UGCS. And that way they can create like a very accurate model of the ground, which is then used to plan the mission. And then if you combine that with our RTK GPS navigation, we can, get them very precisely and accurately at whatever elevation is necessary in order to clear any obstacles that are in the area. I spoke about LiDAR earlier. One of the applications for LiDAR is vegetation encroachment. A lot of our drones are used for that purpose, both here in the United States and elsewhere. We can carry all of the major LiDAR payloads for about 2 to 3 hours. And that is far and away, it really, I think that the way I communicated to customers is, those LiDARs are very expensive. They're upwards of 250, in fact, 250,000 USD. And in fact, a couple of weeks ago, we were flying a $650,000 unit on the drone, $650,000. What we say is the endurance of the Perimeter 8 allows you to make your money back on those sensors, because you can cover more land, you can bid for more jobs for larger areas, and you can do it more competitively, with our platform than you would be with a battery powered drone. You may not even be able to perform that type of work, with a battery powered drone, right? And we're talking thousands of acres of coverage. So we have a number of customers that are using that. Some of them are listed here. Echo 360, Juniper Unmanned, Mazer, Surveying and Mapping, and ESP. The other, one of the other applications, as I mentioned before, is magnetic and GPR surveys. So, we are integrated with Geometrics, the Mag Arrow. We are performing an integration with the Census magnetometer right now for a common customer with JBUAS. And these types of sensors allow you to, and GPR as well, they allow you to see objects below the surface. And this is good for unexploded ordnance detection, IED detection, or finding orphan wellheads. And combined with our active terrain following, that's it's very, very helpful. And actually, I want to show you a video of a flight that we did a couple years ago. Give me a second. So there was there is an organization called Adventures with Purpose, and Adventures with Purpose reached out to us a couple years ago, and they this organization, what they do is they find missing people, right? They find large bodies of water or bodies of water that are nearby where the person was last missing, and they go and they search them. And they contacted us and like, hey, we heard you have a drone that can carry a magnetometer. We'd like to use it for this application. So we volunteered our time. We went out there and we strapped a Mag Arrow magnetometer to the drone, and we flew it for them over an area that they were covering. And let me just play this video real quick. So we went back and forth across this river looking for submerged vehicles with potentially with people in them. We didn't find the person that they were looking for, but we did find a lot of cars that were submerged in this area. And I'll kind of fast forward a little bit. So here's our ground control station, by the way. We were doing this mission, doing a lawnmower pattern with RTK, following the, closely following the height of the flatness of the water. And then here was the data. There you go. Car. We found a lot of cars, and we actually flew another location the day before as well, and we found a lot in the lake that we searched for. That is kind of like a really weird application, but most of the magnetic surveys that are being performed with our drone are usually for looking for wellheads or unexploded ordnance or minerals. Our team, we have 11 full-time employees, and we have about 5 or 6 contractors that we work with. My background's in physics. Graduated from Princeton in 2011 with my degree, my PhD. My team consists of industry professionals. They've been involved either on the operator side or building UAVs in school or professionally at companies such as Skydio, American Robotics, and organizations such as Stanford and Harvard. We're backed by a number of excellent VCs, including Qualcomm Ventures, Jack Ventures. Our board consists of Robert Finocchio. He was the former CEO of 3Com and Sun Microsystems back in the day. And as I mentioned, we're based in Silicon Valley. In particular, we're based in Redwood City. We have a facility that's about 8,000 square feet. And then we have offices in North Carolina and Alabama. For our testing, we do, we have a 700-acre facility in Hollister, California, where we can do a lot of beyond visual line of sight testing, as well as terrain following testing. And we have a manufacturing facility in Fremont, California, and Oakland, California. And that is my presentation. So I open it up to questions. I'm glad to answer them.
Yeah, hi. We have got a question in. The question is regarding archaeology. So the question is, have there been any archaeological applications with the magnetometer that you're aware of?
Not with our drone that I'm aware of. Those have been done. The archaeological applications have typically been done with LiDARs. So looking for changes in the ground. I do know, however, that I believe one of our systems is being used for GPR for that application.
Mm. Yeah, I mean, just to add to that, I mean, it's horses for courses. Magnetometry for that particular, like you said, with that drone, it's you do a lot of geophysics, don't you? Geophysics work and UXO work, and then you're getting into trying to use some of the unique capabilities of the long endurance, like you said, like defense contractors, defense. So that's Yeah, certainly. There are setups that we have, and which you can come and talk to us about afterwards, where we've got quite a lot of experience of doing archaeology. I have spoken to a couple of you already, but yeah, if there's anybody that is interested in using what we're interested in sensors for archaeology, then come and get me. Especially come and talk to me, especially about magnetometers. It's something that I've got quite a lot of experience in. I've actually got a question, Troy, that I wanted to ask, and that is more about the special capabilities of the drone in regards to, there are going to be some parts of the world where you might be affected, the avionics might be affected, or and is that an area that you're able to talk about? Because I know that from our dealings with you, some of the special capabilities in regards to being able to alleviate the problems of jamming and stuff like that. Is that something that is that a feature of the drone?
Yes, it is. So, and we have a lot of experience with that. We have, I don't want to say the total number of drones that we have deployed in those types of environments, but it's a lot. It's greater than 50. Those types of environments are brutal on drones, brutal, right? And we put on equipment onto the drone. It's not our equipment, but we integrate it onto the drone that combats those types of attacks very effectively. In some of these environments, every time it gets launched, it gets jammed pretty much immediately. There are multiple jammers on the battlefield that are constantly attacking any drone in the area. Sometimes they do it in response to kind of detecting the drone, right? If they see it, or if it's got an RF signature, they'll turn the jammer on in response to that. That's something that we've spent a lot of time on, and we are able to effectively combat that. And we have real world experience to prove that is in fact true. In terms of, it's not just GPS, but it's also the data link. So that gets jammed quite a bit as well. The radios that we use, they're top of the line radios to begin with. They're able to combat things like multipath interference, Wi-Fi interference very effectively. But they also have a thing called interference avoidance, which is essentially, I wouldn't call it frequency hopping, but it's more or less like that. You can define the frequencies that you want to use in a broad band, so anywhere from 2.4 gigahertz all the way to 5 gigahertz. You choose those frequencies, and the radios will jump between them depending on the amount of interference that's in the area, so that your data link is never compromised. That is one of the disadvantages that a lot of the modern jammers have, is that they can't jam on all frequencies. They can jam on some frequencies for a limited period of time, and then they have to switch to other ones in order to prevent from overheating. So that's where, having a broadband anti-jamming solution, such as the ones our radios have, is really important.
Okay, that's cool. Okay, great. Just have another question then from somebody on the webinar. I could answer a part of this as well. So, but I'll ask you first, Troy. Is the terrain following radar able to operate with a suspended payload and take this into account to avoid payload collision?
Yeah. So in the development of the radar or the radar terrain following, we had that problem, right? That exact problem. The radar was bouncing off the mag arrow. It was and it didn't happen. It happened whenever we weren't looking. Basically, like we would fly it, it would work, and then we'd fly it again on a different day, and we'd suddenly be getting a return from the mag arrow. So we've done some work to eliminate that, both in terms of software, so being able to detect when a certain object is within a certain range, and then just ignoring that value, as well as just angling the radar in such a way so that the magnetometer is not hit by it. Something that we haven't done yet, but we're working on currently, actively, is making it such that the slung payload doesn't move too much. So one of the issues with some of the magnetometers out there is that they kind of move, right? So like if the drone stops, it'll swing out.
Yeah.
And then it is possible to get in the way of the radar. So what we're doing is we're building fixed mounts for that. So that's not possible to do.
Yeah, that kind of sort of helps me with what I'm going to say. I mean, just for people's information, I mean, I've had a number of clients look at other drones, beginning with M by DJI, where they've tried to sling or slung a magnetometer, a mag arrow at the bottom of it, and they found certainly in windy conditions that with the UGCS radar at the front on the gimbal mount, it actually sways in front of the drone. And they've also seen that on turns as well. So what I can say is that the mag arrow, of course it can be used by a smaller drone with a smaller footprint. However, you don't get the stability you get with something like a Perimeter 8, where it's got a wider footprint, and therefore you get more stability on the ropes. And the angles at which it's held, it's different. So for when you're using a magnetometer like the mag arrow, you really do need stability. So I can see that being really key. You would use a bigger drone, basically. I mean, although people do use smaller drones, I'm not a massive fan, because I do get this issue a lot coming back from them saying, can we use another magnetometer? And on that vein, what we found, certainly in the UK, with it being so windy, you really need to be if you depending on what your application is. There are applications where the mag arrow is it's got the sensitivities. It's great for example, some geophysics and it's then that's fine. But if your application, for example, like UXO, there's some archaeology stuff, you can get away with this, and you've got a smaller drone, then you would use something like the Sensis R4 or R3, and then that it gives you a lot more stability, and it also gives you you don't get those issues with flashing and the radar. But yeah, that I hope that also just gives a little bit more meat to the bone, let's say. Troy, I've got another question in here. I'm going to read it out. It's from one of my Irish friends. He's saying, thank you very much. It's a great webinar. Good. Do you have similar safety features to geofencing and return to home, etc. In Ireland, we can only fly VLOS at present, which unfortunately hinders the area covering capabilities for the drone, for this drone. But it definitely looks excellent to cover long power line LiDAR corridors once the regulations catch up with the technology. So he's talking about VLOS again here, particularly, the issue of safety features for geofencing. You kind of touched on this earlier, didn't you? If you in a little way of with the way that you can hand over control, but I'll let you on that. That's one way you can deal with it. So having multiple pilots, as long as one person takes control before the drone is out of that person's sight, then you're compliant. And the regarding
the geofencing, yes, we have that capability. It's in the mission planning software. All you got to do is define the boundary and the altitude of the fence. And you can program it to do whatever you want it to do. You program it to just give you a warning, to stop in place, to return, and so forth. The return to home, yes, it's got a return to home capability as well. You just program in what altitude you want it to ascend to, and then it'll make a beeline back to the takeoff location. We do get that question a lot. Like the fact that we can fly for so long and travel such a long distance, it easily puts you beyond visual line of sight very quickly, right? But that doesn't mean that it isn't very useful. So these LiDARs, it depends on the application too, but a lot of these LiDAR devices, they're pretty heavy, so they limit your endurance. On the M600 from DJI, for example, a lot of these LiDARs get your flight time down to 10 to 15 minutes, which you don't need, that limits the amount of area that you can cover. You don't need to be beyond visual line of sight for that. They also, the LiDARs typically require you to fly slowly to get good point density. So we're talking like 5 to 8 meters per second, in which case you're not covering a lot of area per time, right? And in that case, there's going to be a lot of battery swaps if you're going to be, covering a large area of land. With the magnetometry application in particular, like that's really, where our drone stands out. We have a customer right now that's doing 12 square miles for a resource exploration project in the southwest of the United States. And they're doing, 25-meter spacing. It's a lot of line kilometers. And that he's totally within a line of sight. But still, like he needs that extra endurance in order to accomplish that mission.
Cool. Are you able to give a kind of an indication of kind of a list price for a standard perimeter array with what we'd call RTK, with centimeter accuracy, and for a kind of like a basic application, like maybe some kind of GPR or magnetometer mission in the UK, but they're having to go long distances.
Yeah, absolutely.
Can you provide some kind of idea, and I know this goes up and down, some kind of idea on lead times right now for the technology if somebody was wanting to engage?
Yeah, absolutely. The base price is $50,000 USD. That includes training. When it's fully configured for the applications that we've been talking about, you're probably going to be in the $75,000 range. And in terms of lead time, we've had a really good year, which is awesome. It's put some, it's made our lead times a little bit longer. So right now we're at about 12 weeks. In about 1 month, that will come down to about 8 weeks or so, depending on what exactly you've ordered. We do a lot of custom integrations for customers as well. So like if there's something that you want it to do that's not default on the UAV, or you have a very particular application, you tell us what it is and what you want, and we'll go and build the technology in for you. So we'll write the firmware, we'll integrate the sensors, and we'll integrate it with the flight controller. We'll make some of that data available on the ground control station. So those are the types of things that we do as well. And then those types of, of add-ons, that's what we call them, they do increase the lead time substantially. So by about 20 to 30%. But yeah, so it'll be about 8 weeks in 4 weeks.
Pretty good. It's pretty good for that technology. you mentioned earlier about marine applications. You just quickly went on to it, but it's an area that I'm quite interested in. I've got a number of dealing with projects at the moment that are marine based. I know there's some things you can't say, and that's absolutely understandable. But are you able to say you know, for example, what kind of MODs you're involved in around the world, or kind of give some flavour of the kind of work, the amount of work that you're doing in maybe the marine sector and maybe sort of like navies around the world and defence?
Yeah. Well, the ones that are public, I have no problem talking about. So yeah. U.S. Navy, they're a big customer of ours. U.S. Air Force, Department of Homeland Security, and then a number of smaller navies. So the Malaysian Navy and the Bangladesh Navy. I'm probably there's more. I'm just drawing a blank right now. In terms of Department, Ministries of Defense, there are a lot of them.
But
yeah,
certainly marine, sort of like marine applications.
Yeah.
Long endurance marine. That's kind of I'm aware that's a very strong area for SkyFront.
Yeah. So strangely enough, that was actually like the first drone that we sold. Was for a marine application for the U.S. Navy, and actually, we performed the first drone to submarine delivery in the world. Actually, if you Google it, just type in drone submarine U.S. Navy and delivery, and like you'll find our drone and some video of it. So we do have experience doing that. We've taken off from ships as well. So thinking, pitching and heaving, that's actually a really challenging problem. And that was the first drone that we sold. So
thanks for that. Just one last question before because time is we're nearly at the end now. But you mentioned before about one of the you mentioned two special features. One was terrain following, this is all terrain following aspect of it, and the second was this get around for the BVLOS question. Sorry, yeah, the staying within VLOS. Is that VLOS an extra feature? Is it an expensive feature? I mean, does it come as it's not a standard? Can you explain a little bit more about that?
Yeah, so it's not standard. It's a software and a hardware addition, so you have to buy an extra radio, you have to buy an extra ground control station, and then you have to buy some special hardware and software that we write to make that work. So it depends on the radio you're using. If you're using our top end radios, like it can be a little bit costly. But we do offer it as well with some of the lower cost radios. So it's about $10,000 to $20,000 more, depending on the per ground control station, depending on the radio that's being used.
Okay, interesting. Okay, so well, we've got no more questions, and I've got no other questions to ask. So it just leaves me to thank everybody. I know we're ending slightly earlier. Which isn't, or it's never a bad thing, but I just want to thank you all for coming along to this webinar. And I want to especially thank you, Troy, for coming along, giving your precious time. I know you're a really busy person, so thanks everybody. Let's end it there. If you have got any questions on SkyFront or on the perimeter array, please get in touch. I work really closely with SkyFront, and like I said, we have got projects on the going at the moment, so it's a really good time. Please get in touch. But yeah, everybody, thanks for joining, and I hope to catch you at the next webinar, which will be about echo sounding kits, both single and dual frequency. So I look forward to seeing you there. Thanks, everybody.
Cheers. Awesome. Thank you.
Bye-bye. Take care.
Bye-bye.